friends, welcome back. Let's continue our discussion on process management in the operating systems topic. Now, the next issue to look at is process scheduling. The process scheduling is necessary because the number of processes are quite more in number compared to the number of CPUs we have, and we know that one CPU can handle anytime maximum one process only, and number of processes are quite more than the number of CPUs. Therefore, some arrangement is required so that all the processes will get some share of the CPU so that each process can execute its task. See this, the process scheduling comes into picture. It is the method by which the operating system decides which process should get the CPU next, and how long the CPU should be provided to the next process. This has to be done considering some issues like the scheduling should ensure that the CPU usage is maximized. Each process should have a minimum waiting time, minimum turnaround time. So in all, the waiting time, turnaround time of each process should be minimized. So make sure that the scheduling is done in such a way that the process faces minimum waiting time and minimum turnaround time. What these mean, we just look in. So when the process wants to execute, it comes into picture, and from then how long it takes to get the attention of the CPU is what we call the waiting time. At the time the process came to existence and how long it took to complete the action is called the turnaround time. That means we want a process to be attended at the earliest, that makes minimum waiting time, and once the process is given chance, then we should ensure that no other process come in between, so that the wait total time required to complete the task also minimum. But yes, we do have different situations where other process do come in between, so we need to minimize the waiting time and the turnaround time. That's what a best scheduling system should be. And also we must ensure that each process gets a fair chance to execute itself. It not that a few get chance and few keep waiting indefinitely, and all that should never happen. Make sure that a fair chance is given to all the processes, and it should provide responsiveness for the interactive systems. When it's interactive system, then we must ensure that our CPU is ready to interact whenever we do get a input from the external world, or when we are working on interactive systems, then the external world may be slow. In that case, instead of making a system wait for the event to occur, we can ask some other process to continue. So that way the usage of the CPU can be improved, that the waiting and turnaround time need to be minimized. So we need to ensure processes get a fair chance, and during interactive systems provide proper responses and all that. Now, how this whole thing happens? So for that we do have what we call queues. There are many types of situations, many states we have seen in the previous session somewhere about the process states. So when the process is ready to run, when a process is ready to execute, or when a new process comes into existence, that means it is loaded from the secondary drive to the main memory, the code is loaded and all the PCB is created for that, and that becomes a process. And once the process is created, it becomes a ready process. So once the process is ready to run, then it is dumped onto the ready queue. So in this case, two processes are waiting to be run. So process 7 and process 2 are waiting. So process 7 is given chance earlier, process 2 will get chance later. That's what this is saying. So from the once we want to allocate a new process, then process 7 gets the chance. After process 7, process 2 will get the chance. Then we have another queue which talks about any process is waiting for data to be read from the magnetic tape. So currently nothing. So there are two magnetic tape unit queues are there for magnetic tape O0, nothing is waiting. Magnetic tape 1, nothing is waiting. Yeah, there is disk system in our computing system. Then there is one disk, that is disk unit 0, and 3 processes are waiting for the disk to be read. So process 3 is in the beginning, then 14, then 6. So if process wants to read from the disk, so it gets to the disk queue, and currently process 3 is waiting for its turn, and whenever the disk reading system is free, then process 3 will get the chance to read the disk. Once that is done, then process 14 gets its chance, and after 14 process 6 will get its chance, and so on. Same way, terminal, maybe some process may be waiting for some key to be pressed. In this case process 5 is waiting for some key to be pressed. So these are the various queues we have. So there are two processes which are in ready state. That means anytime a CPU is available, they are used to run the process. So from the ready state, they can be switched to the running state. And then there are 3 processes waiting for data to be read or written to or from the disk, and 1 is waiting for the terminal. So that's various queues we have in this example. Then what exactly happens? So we said that there are queues and all that. What exactly happens? So that can be explained through the queuing diagram. So there is one queue which we call ready queue. So whenever a new process is created, it goes onto the ready queue, and the process which is in the front will get the chance to use the CPU. So the front in the queue will start using the CPU, and if the process completes its activity, then it gets terminated, or it may be stopped. The process may be stopped for many reasons. One reason may be the process wants to use some IO device. IO device definitely is very slow compared to our processor speed, and we don't want our processor to unnecessarily wait indefinitely for some IO action to take place. Therefore we just stop running that, and the time allotted to that process is stopped, and that process is put onto the IO queue. So there may be many processes wanted to use IO. So all these processes are put under IO queue. So the queue means first come first serve. Whoever asked the IO first will get chance to use the IO first, and second one will use second, and so on. So that may be the reason. So once the process wanted to use some IO, then that process is no longer in the running state. It get back onto the waiting state, and this is waiting for some IO to happen, and it is put under IO queue. And when that IO action is done, then that process comes back onto the ready queue. That's one reason. Another reason, because we may be working on time shared way, then each process is given some fixed time, so preemptive type of scheduling. Then a process is allotted the CPU, so the process from the ready state goes into the running state, and it will be in that running state for one quantum of period, and once that period is over, then it has to move out and come back to the ready queue, and the next one in the queue will get a chance to run. Or the process which is currently running may ask for a fork operation. So when a fork operation is done, then a child is created, and then a child is allowed to execute. And till the child is running, the parent process has to wait. So it will be in the waiting state, and the child process continues to run. And once the child process execution is completed, this parent process is put back onto the ready state. Or the process may be stopped for some IO operation, like want to read data from the keyboard. Want to read the data from the keyboard, then you can imagine the response time of the human. So very slow, and we talk in terms of the keyboard usage rate. We talk in terms of pressing keys per minute, so 60 keys per minute or 40 keys per minute and all that. So we talk in terms of per minute, and we are working with a CPU which works in nanoseconds, and the pressing of the key takes seconds, sometimes minutes, and we don't want our CPU to waste time waiting for that. So instead it is just put under the waiting state, and waits till that interrupt occurs. Interrupt occurs means we are waiting for keyboard, some key to be pressed. So when the key is pressed, it interrupts the processor. So interrupt occurs, and when that interrupt occurs, the corresponding actions with that interrupt are taken, and then the process gets back to the ready queue. So this cycle continues. Maybe for IO request, the running state goes into waiting state, or maybe because of the time allotted is done, then get back to the ready state, or a child is created for operation, then wait for the child to complete and then get back to ready state, or waiting for some interrupt to occur, then wait for that. When that occurs, get back to the ready state. So that's what happens when we work with the schedules. So talking about a scheduler, there are basically three types of scheduler. One is the long-term scheduler, which we call job scheduler. That means it is somewhere related with creating a job or creating a process. So a new process is created. So creating a new process means the code from the secondary drive is copied onto the primary memory, and this happens only once. And once the process completes its job, then it gets terminated. So this happens only once uh, created and once terminated and all other time. So for every process it happens once, and it is quite slow, very less frequently it is done. Then comes the medium term scheduling, where we make the jobs to wait for some event to happen. So the here we have shifted our state from running to wait for some IO request, and this IO request takes some longer time, but definitely not as long as this time it is created and destroyed. It is a very slow process, whereas in one run many times IO activity may be taken, so it's a medium term. And then we have short term, which we call CPU scheduler. So the process which is ready is scheduled and becomes running, and when the time quantum is completed, it is put back onto the ready state, or when other process of having higher priority comes on the scene, then a process with lower priority will be put back onto the ready state, and then the high priority uh, process will be made to run. So that's what happens. It is switching between the ready and running alternately, so it is quite frequently occurring. So that's something about process scheduling and all that. So if you find this any use, please do like, subscribe and share with your friends. Have anything to say, please comment. That's it for now. Thank you.